Okay, hello everyone. Today we are going to be doing on mosaic plots. Last time we just did on interpreting two-way frequency tables. If you guys remember, it was based on like you have two categorical variables. You want to find the relationship between the two. But mosaic plots are generally used for relative frequency. So say among those people who are male, how many percent like this? And those among female, what do they like this? And then based on that, we can better like if males are here and females are here, males like this product better than females. And there were more males in this than females in the survey. So let's take a look and actually see what is mosaic. Some mosaic plots are like this. And just me, they just say here, Noel is a doctor who's screening patients for antibodies for a certain disease. No wonder the disease is impacting people differently based on geographic region. Following mosaic plot summarizes the test results for Noel's patients. Yeah, the following statements can be justified from the mosaic plot. Okay, so now this is just saying that they're screening the patients for antidotes, whether or not they have antidotes, antibodies, or not. So yeah, antibodies, not antidotes. Sorry, antibodies. Okay, antibodies or not, and then they're just trying to analyze here for region based on geographic region. Does that affect? So if person one is from a geographic region one, one is from geographic region two. So here we can conclude that majority of the participants are from region two. Why? Because this is bigger. This is bigger than, let me draw it in different color, this part. Okay, this is bigger. I mean to say this is more, right? This is more. This is more. Region two is more than region one. So we can say here, most of the survey participants were from region two. Most of them. A majority, more bulk was from region two than region one. And then as antidotes or not. Now this one is basically where you can just see it's something like over here. So almost majority of the people in region one, they have um no antibodies. Only a small tiny slice have antibodies. Okay, this is blue, a light blue color. Dark blue means has no antibodies. Light blue means has antibodies. In region two also we see the same. Majority of the people, the bulk of the people have no antibodies. They're all dark blue. Only a small little slice have the parts. And if you try to compare here, it's almost equal to each other except region 1. If you see, it's a little bit higher. If you see a little bit, I think it's almost there. Yep. But I think that's what kind of we can kind of conclude from here. Region 1 is actually a little bit more. Now, but almost it's equal actually. Mathematically, it will be equal, but a little bit difference might be. Now, here from these statements, A, B, and C, we can see there's three options. Following statements, we can just try from the mosaic. Patients from each region are about equally likely to have antibodies for that disease. Okay. Patients from each region were about equally likely to have antibodies for the disease. Does seem like it. We're about. They're not exactly equal likely. They're about equal likely. They almost seem like the same. Though region one seems a little bit higher, but I think it's almost about the same. Like if you see a little bit higher, right? But yeah, it's almost the same. You can say mathematical terms, and then full screen, the same number of patients from each region? No. Region 1 is actually a little bit less. So we can say region 1 is actually more or equal. It's less than region 2. I took majority of the participants from region 2. And from region 1, there were less patients or less participants, less observants he took. So Noel just kind of, he gravitated more toward region 2 than region 1 in his study, in his research study. And then the majority of the patients in region 2 have no antibodies to the disease. Well, yes. Majority of the patients in actually both regions have no antibodies to the disease. There we go. Yes. Yeah, region 2 is wider. Yes, that's why we cannot justify this. Okay, that means actually he screened more patients from that region, from the specific place, specific geographic region. Okay, now coming to this one. So Dr. Harris is curious about whether her patient's body images match their relative sizes. So the body image is kind of this matching their relative size or not, as measured by a body mass index. So something like a body mass index we have. Uh, Let me just check here with the body mass index. Yeah, body mass index is, just a numerical value they get for a person's height and weight just as a screening tool. I think it's like an overweight, obese, yeah, normal weight, underweight, just, see that person, how their health is. That's basically a body mass index. I think it's basically their, wait, what is it? Okay, it's their height and weight compared with each other. Based on that, they can say if they were likely to get heart disease or diabetes or those kind of diseases. So That's what they're trying to compare here. The body mass index. Then based on body mass index, I have to say in here that if they're overweight or not, and if they think themselves are overweight or not. So basically, some people might be thinking they're not overweight, but they are. Some people think they're overweight, but they are not in reality. So here are the results here, and then they're just saying which of the mosaic plots currently displays these results. Now this one should be where a yes, no should be there. Think they are overweight is yeah, A, B, C. We see all the three options. They're all on the left. So think about their thinking process is on the left, then the basically the overweight position that could be on the far. So now yes and no. So how many people are actually yes? Let's see first. 87 yes, 33 are not overweight. So that means the bulk of the people should be overweight. They should be overweight. I mean, you should be thinking they are overweight. Sorry. And then the bulk of the people, if you've seen overweight, they are also yes. So bulk of the people are actually overweight, right? Because 84 and 36, if you see, and over bulk of the people even think they are overweight. So yes, that also matches. That means this graph should be having, let's take a look at the A option. Now A here shows us yes and no. Okay, so now yes and no are equal, right? Because if you guys see here, this is equal. And we don't have equal. Yes and no, 84 and 36 can be similar to each other. They're like vastly different. 84 is vastly outnumbers 36. 84 must be like, yes should be a little bit more. So yes should be something like this. No should be something like that. Okay. No should be smaller. Yes should be bigger. We're just talking about they are in reality overweight or not. Okay, not about the thinking process, the thinking part, whether they think or not. In reality, are they overweight? We're just seeing this part, this with these values. So based on that, we can say we can conclude no, A doesn't seem like an option. It actually seems like to be equal here in A, whereas 84 and 36 can't be equal. 84 of the participants are overweight and 36 are not. So, and then yeah, in total we have 120. And then in B does seem like it, right? Yeah, B does seem like it. Because B has yes for over. Yeah, bulk of the one should be yes. There should be no. So B does seem like an option. Let's check C first though. C if we see, for C option, it does seem like it shouldn't because no actually in no, there actually no should be less. No should be less wider than yes. Okay, no should be less wider than yes because yes is about carrying the bulk of the participants. So these seem like an option here, but let's verify the other data as well. Like not overweight, I mean not thinking and thinking. So if they think they're overweight, what is the scale here? I think they have the scale. Think they're overweight. Yeah. So no, if they think they aren't overweight, that does match because bulk of the participants, if you guys see here in the yes category, okay, 74 of them think they are overweight. Okay, the overweight participants, 74 do think, and then there are 10 people who are over because they're in the overweight column. So they are overweight in reality. 84 are overweight, 74 are thinking they are overweight, 10 are not. Therefore, we can conclude safely that yeah, B does seem like yeah, because no is actually a small column. It's almost like just 10, and 74 is actually seven times bigger. It's like a big jumbo column. That makes sense. And then for no, if we see for the no part. So if we see for this part, let me just point out this one. So this one, if we see, we know we have to see whether they think they're overweight or not. So let's see that. So if you go up here, well, actually in the participants column over here, yeah, now here actually those who are not overweight, only 13 of them are thinking they're overweight. 36 are not overweight. 13 are thinking they're overweight. 23 are thinking they are not overweight. So actually, the people who are thinking not overweight are exceeding the people who are thinking overweight in the not overweight column. So take a look at option number B. Yeah, that does seem like it. You guys see. You see this column is bigger, the no column is bigger than the yes column. Like if you guys match here, this is yes. Light blue is yes. Blue is dark blue. That does match over. Okay. So we'll be choosing option number B. Let's check that out. There we go. Okay. Yes, it makes sense, right? Like, yeah, they can even proportionally split them like this. So let me just close all the tabs here. Yeah, we can even split them like this. Let me. Hmm, okay, I'll just move this one. Okay, so yeah, this one should be the option number B. Select. And yeah, and actually we can do something like this. Going on how we do with 70 over 84. So 84 are overweight now, 74 out of 84. That's relative frequency. So 88% think, 88% who are overweight, they think they are overweight. 12% who are overweight think they are not overweight. And that become able to conclude more easily and more safely, more accurately in general. And then 23 is 636. So 64% who are not overweight, they think they are not overweight. And 36% here think that they are overweight, whereas in reality they are not. So yeah, that's what we can conclude. Okay, now if you try to see here, let me just run this. Okay, now if you see here, Mrs. Chen is surveying a sample of 150 families from three districts to see whether they have internet access at home. Here are the results. So district one, district two, district three. Three districts are there. Like so, 400 from district one, 200 from district two, 350 from district three. So bulk of them from district one. And how many have internet access we can just see. So 180 divided by 400. That we can say that these many percent of students. I think that's a little bit below 50. But let me just check the math here. So 180 to 20. Oh, sorry. I think it should be 400. I'm sorry. Good one, yeah. So 45% of the people in District 1 have internet access at home. 55% of the rest, like 220 over 400, that's 55%, don't have internet access at home. Similarly, we can do for the others as well. But I think the more easier way is just, kind of match around and see like which has bigger and smaller. That's a more easier way. But we can even calculate relative percentages for the relative frequencies and then predict on that what music plot we should graph over here. So we take a look over here. What music plot should they use? So District 1 should be carrying the bulk. Yeah. Now District 1, if you carry the bulk, now A and B, there are two options to compare where actually, yeah, now here, if you dare to compare this part, this one makes sense, right? Because District 1 has the majority. And actually, yeah, 400 out of 750. Yeah, this one makes sense because there's a little bit, actually, 400 is almost half of 750, because 400 is half of 800, almost half of 750. That seems like it is almost covering a half piece. So yeah, that we can conclude, but B also seems like an option here, so let's even check B actually. Now, yes and no part. So how many students have access? First of all, let's see. 421 and 329. So the students who have access at home, okay, this month, total of 750, 421. So it's slightly greater. So those who have internet access are slightly greater than those who don't have internet access at home. Check B. B also seems like, yeah, because yes is a little bit more than no. Okay, now let's try to compare. Now, how do we compare which one to choose here? So now we're going to compare for A. Let's see for the yes and no columns. So now for the yes column, if we see the yes column for the first district. Okay, now yes is 180. So yes should be actually smaller, no should be greater. Yep, that makes sense. Now for the second one, so the second district, 143 is greater than 150. 143 is greater than 57, right? 98 is greater than 52. This part like this. So now, so the yes part should be more. And if you see here, yes, this part is bigger, right? This part is bigger than this. This part is bigger than this. So yeah, A does seem like a correct option. There's nothing that is violating A here. Maybe there could be something in B. Let's still check that. So for B, District 1 if we see. Uh, okay. So District 1 if we see, District 1 has actually, what, yes, okay. So District 1, no is more, okay. And then District 2 is there where 143. Okay, this is yes. That also seemed like it, right? Yeah. Okay, this one is also 98 and 52. Hmm. District. Okay, plot B also seems like it, right? Yeah. Okay, but I think there we do see some major difference, and that is there any difference? Let me see. Wait, 143 and 57. Okay. And then what do we have? 98 and 52. Well, let's check A and see if that is correct or not. Okay, it's correct. Let's see, I think the explanation here. What was wrong in because A was correct, that we know. But for B, conditional distribution of district by internet access, so we get. Oh yeah, B is actually correct, but yeah, what they want here is they want to see if okay, this one's important here. I see. So they just want to see whether she can predict whether a family has internet access based on which district they live in. So they want to see based on the district whether or not they have internet access. Not that whether or not they have internet access, which district they could be. So yeah, wherever you see based on whether family has internet access based on what? Based on what? Based on district. Based on district means district should come in the X column. I mean in the X coordinates in the bottom. So whenever they say based on districts, that base should be here. Okay. If they say based on whether they have internet access, then yes, no should be there. That should be option number B. So B and A are technically both are correct, but here they wanted us to use A because that's giving them information based on which district. Okay. This one, B is giving option, B is giving answer to based on they have internet access or not, which district they are most likely to live in, or whether a family lives in district 1, 2, or 3. Based on they have internet access or not. So here we can actually conclude that, based on they have internet access, if they have internet access, a bulk of the participants live in district 1, right? Yeah, and then a smaller percentage live in 2, and the smallest subset live in district 3. But we want based on whether they this based on their which district they live in, whether or not they have family. I mean, whether or not they have internet access for the family. So therefore, A option is there. Okay. Which of the following statements can be justified from the mosaic plot? Let's go to this. Like the human resources specialist, he knows why this company promotes employees differently based on the family demographics. Yeah. So he's just trying to see whether or not the family demographics is kind of hurting or, advantaging. It's advantageous or it's kind of disadvantageous to their promotions. Is it hurting or is it benefiting? So the following mosaic plot is just summarizing the promotions in the past year for employees in Zach's company. So children and no partner. Okay. Some they're like just singles. And they're like no children, they're just couple. And then the children and partner. So they have like a whole family. And then promoted or not. So that's what you want to compare. So now bulk of the people, actually they're children and no partners. So singles are a little very less included here in this part. Okay. In the company, the singles are very less. Majority of the people are with no children. They're just couples, I think. And then children and or they could be just, with no children. Maybe just couples or someone, but just no children. And the children and partner, they are just considered the second subset. Okay. So first is no children, second is children and partner, and then third one is children and no partner. Now they're promoted or not. So with no children, they were actually more promoted, right? So bulk of the participants, actually the people with no children, they are more likely to be promoted than someone with children and partner or someone with children and no partner. Yep. So which of these statements can be justified from the mosaic plot? Let's go this. Employees with children and no partner were least likely to be promoted. Well, with children and no partner, they were least, yes, they were least likely to get promoted. Yes. Why do we see? Because the yes promotion is very, very small. Okay. This one is almost still up here. So it's almost like a big percentage, big half the percentage that's getting not promoted. My internet connection is which. Let me just connect it. Oh, okay. My recording. Okay. I just connected my Wi-Fi. Okay. And so where do we go? Okay, yeah. So basically, let me send this, yeah. So they were really like to get promoted because their bar, if you try to compare over here, let me just go ahead and pen, yeah. Their bar is like smaller. So this bar is a little bit smaller. So the majority of people who were getting promoted were with no children. So now less than 20% of employees were promoted. Now this part actually, how do we calculate? Less of 20%. Well. Yes, this does seem like it. You know why? Because if you see this is 80%. And if we see this is all 20%. So I think 20 less than 20% were being promoted. We don't know the exact percentage, but it does seem like less than 20% based on this data. And then about half of the employees have children. Well, about half the employees have children. Well, let's see. Actually, children and no partner. So well, we could say actually the third statement is also correct. About half have. Because if you compare this part, okay, children and no partner, children and partner. So if you compare these two, those two kind of combine up together and they could make up like about a half, and no children would be the other half. And yet no it's children. Okay, I see. So with children means they just have children, they don't have any partners. Yeah, they aren't actually technically singles, they're just like with children but no partner, there's like a single parent. So yeah, basically my mistake, my bad. It was just yeah, with children and no partner means just a single parents. No children means yes, I think they should be singles or couples. Children and partner means just a whole family. Okay, so yeah, let's check this out. There we go. Great, awesome. We didn't. Mosaic plots. Let's do quiz one. Okay. Two-way table of column relative frequencies. So column relative, remember, column relative means we have to make the assumption based on their column. So given that a person is a family member, so 25% of who have a family member as a role model are high school graduates or something. We have to make based on their column. Okay, we have to make assumption based on the column. So just summarizing the survey data on whose person's role model is some highest level of education. They're just showing like role model as family member, friend, or acquaintance, or stranger, and then whoever has them, we can just say, okay, this person, given that this person has a friend as an role model, 25% of those guys have finished some college, 90% of those guys have finished bachelor's degree, 12% have finished an advanced degree, 32% have finished high school, and 12% have less than high school. So basically, the people whose role model is actually a family member, they are least likely to finish something less than high school, right? Because 9% is the list. But we can't say, the person who has completed bachelor's degree, in them, the person is least likely to have, say, stranger as a role, even though this is actually the least, because all these uh probabilities, all these, not probabilities, but these frequencies, they don't add up to one. Okay, we got to add up to one. Here we see these all add up to one. These all are adding to one. They're column relative frequency. This is not row relative frequency. So yeah, therefore we can't make any conclusion based on the row. We have to make our conclusion based on the column, based on which column they are in. Let's go to the options. Based on the data, which are the following statements must be true of the people surveyed. Person whose role model is a family member is least likely to have an advanced degree. Well. Then a person whose role, okay, the role model is a friend or acquaintance. Well, this option, if you take a look at, whose role model is a family member, is least likely to have an advanced degree. So, well, they're actually least likely to finish less than high school, not least likely to have a degree, because 0.14 is more, right? But if we compare that, a person whose role model is a friend or acquaintance is less likely. Okay, yeah, they're trying to compare between two. Okay, I see. They're trying to compare between the person who is a friend and who has a family member as a role model. So if you try to see here, a person is actually more likely. Yeah, so the statement is wrong because person is not less likely. 0.14 is actually more. So they are more likely to actually complete a high advanced degree. Take a look at option B now. Role model is stranger. So a person whose role model is a stranger is less likely to have high school. And some college is the highest level of education. Is more likely to have is more likely to have high school. Actually, that is true. There are more likely to 40% of them are more likely to have high school and some college. This checks out. Now, if you see, a person whose highest level of education is a bachelor's degree, well, this conclusion we can definitely make. We can say about their education levels based on that. So we have to make column relative frequency. We don't have row relative frequency. Person whose highest level of education is less than high school, no, D is also wrong. So D and C are immediately ruled out. These are only ones we can choose. Safely choose, yes. Okay. Teams in the National Football League, NFL, in America are divided into two conferences, AFC and NFC. So teams have animals as their mascots and those do not. So some of them have animals like, a cute panda, or cute like a bear or something. And then others don't have any animal mascots. The following table displays the data. So this is just showing like if a person like I belong to AFC or not. And then if I have an animal mascot, I belong to ANFC and I have an animal mascot. I don't belong to NFC, I belong to AFC and I have a non-animal mascot, maybe. And if I belong to NFC, I don't belong to AFC, but I have a non-animal mascot. So the other four things. So four data groups here. And if you try to take a look at how many teams have an animal mascot, we have to see how many teams are there, first of all, who have an animal mascot versus who don't have. So, well, regardless of their team affiliation, NFC or AFC, regardless of the conferences, I mean to say, they're in the NFL. They have 7 plus 8, which is 15. 15 of them have an animal mascot. 9 plus 8 is 17. So 15 have animal mascots, 17 have a non-animal mascot. So we see here how many teams have an animal mascot. There should be 15. And in total, there are 22 teams, just to keep in mind. Yeah. Okay. What percentage of the teams are in the AFC? Now here they're just showing here's what percentage of the teams in AFC. AFC, how many teams first of all are there? 16. How many in total? 32. So it's actually 16 over 32, which is about a half or 50%. So 50% in EFC. And in NFC also we see 16, so NFC also has 50%. Okay, awesome. Okay, great. Now we're doing mosaic plots again. Back to mosaic plots. So Mr. Quintana surveyed the students about whether they disagreed or agreed with the statement. I like school lunch. So no, who likes school lunch? They're just trying to agree or disagree with the statement. And then just recording the income level of the student's family and the response for a random sample of 330 students. Here are the results. So the results are just shown on the screen. We just see over here. And it's just like a low income, middle income, high income students, and whether or not they agree with liking or disliking. And then, so 42 maybe say like, in the low income. 73 say like in the middle income, high income 55 say to like. And these are all the different students surveyed. Total are 330. And which positive plot correctly displays the results? Yes. Let's take a look at the options now and see. Now low, middle, low, and okay. So bulk of the people should be in middle, right? Because middle is the highest, 138. Then if 105 and 87 are the peak ends. So middle is the bulk. And actually middle always has the bulk, yes. So now we need to compare here if how many out of how many disagree out of those specific. So if we try to get the percentages, 63 out of 105 disagree with us, 65 out of 138 disagree, and 32 out of 87 disagree in the specific income groups. So low income, 63 out of 105 disagree. How many percentage is that? 60. Let's write it down. 60. What about 65 by this thing? What do we call 138? So yeah, 65, 138. Let's see. 47. Okay. So 47%. And what about the high income? High income, how many don't like school lunch? Well, it should be 32 over 87. Less than half, I guess, almost, right? Yeah, 36. Less than half. Yep. 36. Let's just keep it 36. We don't need to round and count into decimals. We are just trying to map around and see which are the highest. So a majority of the low income students they disagree that they like school lunch. A majority, I would say, majority of the low income students they disagree that school like school lunch. Middle income is kind of half and half, but a little bit more than half agree that they like school lunch. And then for the high income ones, actually, almost all of them say they like school lunch. Almost like 64% would be saying, right? Because 36% are saying not. 32 over 87 is 36%. 36% disagree. So yeah, based on that, we can just see now. So the disagreement is actually this dark blue. So dark blue actually should be the highest for low. Then it should be for middle, it should be a little bit less. So it should be something like this. For low, it should be like this, then like this. And then for 36, a little bit less. So yeah, again, like that. And this actually quite closely matches with A, if you guys notice here, right? A quite closely matches. B doesn't match that. Because, 60 and 37 equals. It should be 60, 47, 36. Like a ladder. Like a downward staircase. It's kind of that way it should be. Like 60, 47, 36. B doesn't match that. C also doesn't, yeah, C also doesn't quite match. Because like going this and this. It can't be going up. It should be going down. Straight like that. So A is, I think, the most closest option. There we go. A is the most closest option over here. Okay, now coming to here. Let's see, I think it's okay. Mr. Gregory sold several cars this week, so now here's some data about the cars he sold. So now when he's selling cars, the individuals in this data set are what? Are the cars he's selling, right? They shouldn't be the customers. They should be the cars because he's selling several cars this week. What is he selling? What is the data focused on? What are all those variables on these cars? So it's basically cars. So this is the identity, okay? It's something like an ID of the car. So my name is Altima or Accord or Camry. That's a specific car. That's a specific individual, which is being described by retail price, miles per gallon, seats, and navigation. Those are the four variables, of which actually three are only quantitative because three are numbers. The other one is not a number. Mile navigation is just categorical. So we can say actually cars as individuals, of course. And how many variables? Yeah, four. Four of which three are quantitative. Yeah, three are quantitative, and one is categorical. Yep. Okay. Let's see here. Lolo asked classmates what types about their favorite types of movies and graphed the results. So just asking the favorite type of movie to her friends, Lola, and then she's just graphing about the people here. So someone is like, number of people, how many people are saying mystery, they like a mystery film? I would say 16. 16 is saying, they like mysteries. Cartoons is loved by 10 people, right? Because it's between 8 and 12. Adventure is also loved by 10 people. Scary is being loved by 6. Comedy is being loved by 20. Okay. What are the following types of movies were the favorite of fewer than 14 people? For this case, now we need to see which of the following were less than 14. So if you see here, 20 like comedy. Scary is being loved by 6. Adventure and cartoon both are 10-10. Mystery is about 16. So basically only three of them, right? Cartoon, adventure, scary. Those are the three ones that are less than 14. Other ones are more. 20 and 16 are more than 14. 6, 10, and 10 are less. So cartoon, adventure, scary. Cartoon, adventure, scary. Okay. So markers are pretty easy and pretty interesting and fun to do. But okay, let's do the Venn diagram now. So Venn diagram is basically all about. I think it's I have. Hmm. Venn diagram is all about veterinarian is asking her 18 patrons if they have a dog or not. She also asked each patron if they have a cat. Venn diagram is just below showing the data she collected. So below is the two-way frequency table. If they have a cat or if they have a dog, then how many have a cat and have a dog? Well, seven. They're sandwiched between the two. How many do not have a cat but they have a dog? Well, how many do not have? Yes, five, because five should be here. So yeah. And how many have a cat but do not have a dog? That's six from here. Oh, sorry, I think I just made a mess. Yep. And if you want to change colors, okay, let's just find. Okay, so now zero. Zero, if you try to see, zero is actually where no people have, don't either cats or either dogs. They don't have any. Now 7 plus 5 is 12, 12 plus 6 is 18. So yeah, in total 18 patrons that matches this value. So yes, we know we are correct. Let me erase this. So 7, 5, 6, and 0. Let me just fill that values in. 7, 5, 6, 0. Okay. I think we'll be switching gears up next session. Let's just see what's coming up. Okay. Great, great. We will be doing is basically on conditional and marginal distributions. So yeah, guys, we'll start is in the next session. Till then, take care and bye.